Well, hi, welcome to My Favorite Mistake. I'm Mark Graven. Our guest today is Chris Lewicki. He is an astrophysicist, an engineer, and an entrepreneur. He's interested in developing strong and thoughtful foundations for the near future space economy. He's a multi-time co-founder or founder of organizations. At his first, he co-founded and was CEO of Planetary Resources, Inc., or PRI, which focused on the prospecting, development, and use of resources found on near-Earth asteroids. Before entering the private sector, Chris was a key member of NASA's Mars exploration rovers and the Phoenix Mars lander, serving as flight director for the Mars rovers Spirit and Opportunity, and as the surface mission manager for Phoenix. Chris has both bachelor's and master's degrees in aerospace engineering from the University of Arizona. He's recipient of 2 NASA Exceptional Achievement Medals, and this is cool. He has an asteroid named in his honor, 13609 Lewicki. So, Chris, welcome to the podcast. How are you?
Glad to be here, Mark. One correction in the intro. I'm not quite an astrophysicist, although I admire astrophysics.
Oh, I said that wrong.
Maybe astrofuturist.
That is my mistake. Astrofuturist. I have a friend of mine who's an astrophysicist who's going to come watch the total eclipse with me. So
excellent. That'll be an exciting day for everyone.
Are you going to be anywhere near the path of totality?
I'm going to travel to experience it with my family, who live right on the line of totality.
Oh, great. Excited about that. So astrofuturist, my mistake there. It's fair to say you are a rocket scientist. I think you're the first rocket scientist, quite literally, rocket scientist that we've had on the show.
I'll accept that title. They make a lot of mistakes. They just hopefully make them before they show up on TV.
And I think we're going to have a chance to talk about that here in the episode. Of the different things that you're involved in, I'll link to Chris's website and LinkedIn profile, and you can get that broader view. But what else would you highlight in terms of the things you're working on these days, Chris?
Well, I'm interested in the space industry. I also call myself a space industrialist. Anything that creates infrastructure and allows companies, businesses, communities to go to new frontiers. We've been doing it for all of human civilization. I think space is just another ocean to cross. Yeah. So with that, I'm involved with organizations like the Creative Destruction Lab, which is a startup accelerator, where I help mentor startups and certainly learn from them and the other mentors like Commander Chris Hadfield, who was commander of the International Space Station. Also involved with another space explorer, Anusha Ansari, at the X Prize Foundation, where we're dreaming up new prizes to create breakthroughs in a lot of different areas. The ones we're interested in space now relate to the problem of space junk. So we hope we can launch a new prize in that area soon. And then just lots of helping out different companies. I think I find myself in the role of helping out founders and companies more often than starting them myself these days, but still always looking for the next moonshot to take.
Yeah. And we are taking, I guess we as the U.S. and other countries are taking more moonshots quite literally these days and in the near future, right?
Yeah, very exciting. We've seen, things crash on the moon, things not quite crash on the moon, but there's a lot of traffic headed that way. We've many exciting things at Mars, still have robots at the edge of the solar system. And what's exciting for me is just more and more of it is outside of the activity of governments. They're still certainly a big partner in that, but a lot of this is just slowly trending towards normal commerce and maybe even a little bit of tourism and all those normal things that make up our daily lives.
Yeah. Because recently there was a lander that landed on the moon, but then tipped over. Do I have that right?
There were actually 2 that could fall under that description.
Yeah.
The Japanese had a mission called SLIM, which was supposed to do a little bit of a belly flop. And it did too much of a belly flop and kind of ended up on its head. It has some interesting pictures from that. So that was by the Japanese Space Agency. A private company just last month called Intuitive Machines was the first private company and the first U.S. entity to what they call soft land on the surface of the moon since 1972 was the last time that Americans did this, and they came in a little too fast.
Yeah.
So a little bit morbid, but kind of broke their legs at landing and tipped over, and then from that point whispered out some messages for the next few days to relay data and images, but we call that a qualified success. It's you made it to the surface of the moon and you were still operating. So I don't know if someone probably could have walked away from that landing, maybe limped, but then they would have ran out of oxygen, so it would have been over anyway.
Well, and thankfully, as an unmanned mission, we're rusty, or there's new technologies. I'm sure a learning opportunity for everybody involved, or anybody who's going to go in the future, right?
Yeah, absolutely. It's the great thing about these missions, and just the change in risk profile of public-private partnerships. Companies want to innovate. They want to cut what might be unnecessary corners, introduce new technologies that maybe haven't been proven yet, and do things that have been proven to work. The benefit of that is you can do things faster, you can do them better, and usually can do them for lower cost. The compromise in that is it doesn't always work. But like Elon Musk has shown with SpaceX, who's had many exciting launches in the last year. It's only through actually trying that you actually figure out from Mother Nature and physics what was a good design and what needs improvement. And there's no better way than to guess at it than to go out and try to do it. So that iterative approach to design and learning, and failing farther down the road each time, I think, is actually necessary for really hard types of unprecedented progress.
Yeah, that's very well said. And there's a lot more to talk about, but I want to get into what's usually the first question here. The things you've done, I'm curious if this will be a story from time working on space missions or as an entrepreneur, or both. Chris, what would you say is your favorite mistake?
I think my favorite mistake is the time I nearly killed $500 million Mars rover.
Oof. Nearly.
That's a key phrase in that sentence. And this is a story I've told a lot of times in my career, and it wasn't one I was always ready to tell. You kind of go from being embarrassed about things or being a bit self-conscious about it, but like over time, just kind of understanding the lesson from it. So when I was in my 20s and in my first big job as a rocket scientist and aerospace engineer, I was working on the Mars rover program at the Jet Propulsion Laboratory in Pasadena. And we were building the Spirit and Opportunity Mars rovers. It was the February or so in 2003. And it was just a couple months before launch and like 2 weeks before we were going to box these things up and ship them to Cape Canaveral, Florida, where they would be finish their testing and go on top of the rocket. And one of these things that's special about these rovers, you can see them behind me, is they have lots and lots of moving parts. And all those moving parts have motors. And the motors at the time we were brushed motors. And those brushes are things that could break. And we put them through a lot of rigorous testing. We wanted to make sure that all the brushes still worked before we sent them to Mars. And there was really only one good way to do that. And, the way to do that is to get a set of test leads, plug them into the right spot in the rover, and give it a bunch of juice. And you'd watch what happened as the motor spinned up. And if the motor was healthy and everything was in working order, you'd see a real nice clean profile as it just kind of took that energy and converted into rotation. If that worked, that you had a clean, healthy motor. And if it was anything other than that, it was something to look into. The dangerous part about that, of course, is we didn't exactly design the rovers to be tested in this way. And someone thought about this in the course of doing this, like, we should do this. So we had to essentially write, 50 custom little instructions of, which connector and which pins and How do you take it apart? How do you put it back together? And, which you pull a connector apart. It's like, okay, is it the left side or the right side? Because there's 10,000 options. So you had to look at all that. So my job was to write those instructions, and, with one other person, go out and do those tests. So I was probably, 15, 20 tests into 100, on the second shift of a work day, probably getting to, I don't know, 15, 16, 17 hours that day.
Mm.
And
Is that was being shipped out the next day? The time pressure?
it wasn't the next day. It was the next week or two. But, you've got to fit all these different things in. And the moment of opportunity was we were testing Spirit in this case, which was the first one to launch. And they were doing a bunch of software tests on part of Spirit. And we were going to do these motor tests on the robotic arm, which we could detach while they were doing the software tests. So, set everything up. And, one of the things that I needed for the test was a voltmeter, a multimeter. So one of the people on the floor, John, said, oh, there's one right there, grab that one. So it was plugged into some stuff. So I carefully removed it, checked everything out for the test, looked good. And, then it gets to, everything checks out. Now we're going to actually do the test. And push the button. We looked at the plot, and it was kind of like, oh, that doesn't look right.
Uh-oh.
And, I don't know, time dilation or out-of-body experiences or whatever it was, but it didn't feel like it took long at all for me to realize we just tested the wrong direction.
Yeah.
We should have tested right. We tested left. So, being well trained in, working in the clean room at the time, the first thing I did was to tell Leo, my friend, who was doing the software testing, like, hey, we had a little bit of a problem. We did the test on the wrong interface. And Leo's like, oh, yeah, well, we just lost telemetry a little bit ago. And I'm like,
yeah.
Oh, my God. You never want to hear that. It's never good to lose telemetry with robots.
Yeah.
Unless you are intending to do that.
Right.
So at this time, John, the guy who is telling me about, which multimeter to take, he had caught, so everyone's listening in on the headsets that everyone's wearing. And he started unleashing a string of profanities. There's a master course in swearing. And, we did an emergency shutdown of everything and kind of cleared out and had to figure out, well, what the heck just happened?
Right.
So I am shell-shocked at this point.
Right.
Because, did a bad thing. Something that didn't like it was supposed to happen happened. We're looking at everything and, as people can continue to triage the situation, someone tells me, well, write down everything that you can remember that led to this. This is failure investigation 101.
Yeah.
And this is the point where I am starting to well up in tears and everyone else is starting to move away from the scene of the crime.
Yeah.
And really I'm feeling pretty bad.
Yeah. I can't imagine.
And, we're kind of looking through this and, I can't remember exactly kind of the order of the events, but the people who were familiar with the details of the design and exactly what happened is like, okay, well, what you did wasn't good, but we can't figure out how you would have lost telemetry from it. It shouldn't have done that. So clearly we don't understand what happened.
Yeah.
And when your computer has a hiccup, often the time is like, oh well, turn it off, turn it back on. So
right.
It works for $500 million Rovers too. It's like, well, let's just turn it back on, and maybe it was a glitch or something.
And we're probably not going to make it worse by doing that.
Well, let's figure the best way to figure out what happened is like, maybe it was some glitch, and we are in the process of building the thing. So it's not quite completely checked out and it's not completely assembled. So we turned it back on and there's a little blinking light that is kind of what we call the heartbeat of the rover. That means that it's got through all the processes and it got to the point where everything's running and running appropriately. And it takes a little bit to get to that blinking light. And when it should have started blinking, it didn't. I waited a little longer. It didn't blink in. It was just no telemetry, no nothing. Wasn't doing the rover things it was supposed to do. And it's like, okay, that's definitely not good.
Yeah.
And, so this is the point at which, okay, we broke it. And I'm the one that broke it. They're calling in managers at 11:30 at night, waking people up. And at this point, this gets into a little bit of the lessons learned.
Yeah.
But a gentleman named Ernie bravely walked over where I was and consoling me and kind of, puts his arm around me and pats me on the back. And he's like, remember this feeling the next time you have to sign on the dotted line for something.
Yeah.
And this is kind of, now it was, maybe an hour later, I'd never felt that bad. And now I was at a new depth of just absolutely feeling like this was the worst mistake in my life.
Yeah.
So went home, probably 1, 2 a.m. at this point, kind of telling my wife about the experience. And like my sense was like, this isn't a thing that you keep your job with, hundreds of millions of dollars of government asset. It's broken. I'm going to go into work the next morning and get fired. So I did that. Went into the work the next morning after a bad night's sleep.
Yeah.
Also, it wasn't just that I just did this horrible thing. It was I'd been working on this project for a couple of years at this point and was really excited about sending 2 rovers to Mars.
Right.
And now, we're probably going to send 1 rover to Mars.
There's that disappointment, regardless of the cause.
This is like the topic of thing of like, this will be remembered in history. That it is a true rover mission. And then because of some idiot's mistake, it becomes a 1 rover mission.
Yeah.
So the next morning, came into work, and we're still, trying to figure out how to solve the problem, being NASA and a bunch of engineers.
Yeah.
And we were able to piece together, it's like, okay, well, remember that multimeter I told you about that we were using to test? Like, tell me more about that. Where'd you get it? Like, I got it from over there. I'm like, oh, well, you shouldn't have removed that because that's actually needed, for the test configuration. And, let's try powering it back again, but we'll put the multimeter back in place because, the multimeter actually was measuring something related to the telemetry. So we plugged it back in, we closed that circuit, powered it back up. The blinky light starts blinking, telemetry flowing. And it was like, to that point in my life, it was the greatest relief I've ever experienced.
Yeah.
And, I did not kill the rover that day.
Yeah. Wow. Go ahead.
Well, no, there's probably more questions you can ask me at this point. But that was kind of like, that definitely was the greatest mistake of my life. And I have drawn several lessons from it.
Yeah. And I definitely want to explore that. I do have questions. In layman's terms, I'm not an electrical engineer, not a rocket scientist, but when you say that it was being tested in the wrong direction, was it a matter of literally kind of connecting a cable in the reverse direction, or like trying to jumpstart a car and you connected to the wrong polarity terminal, or there was a little more to it?
Yeah, well, it's kind of like you've got a connector, and part of that connector goes to the motor, part of that connector goes to the battery, or the computer, or whatever it might be, and I picked the part that went into the computer, instead of the part that went in the motor. And one is designed to take a bunch of energy, and one is designed to give a bunch of energy.
Yeah. Okay. So that's where it flowed the wrong direction.
Yeah, and the thing is, in the electrical engineering terms, I'll tell you a secret. All electrical circuits work on magic blue smoke. And the key is to never release the magic blue smoke, or the electronics will stop functioning. So, if you've ever burned a piece of electronics and you can smell it, that's why it stopped working.
Yeah. Yeah. Not a good smell, not a normal smell. I'd love to kind of talk through some of the other, factors involved in this. You were doing such new, innovative work. I think it's a fascinating detail that it wasn't designed to be tested in this way.
Mm-hmm.
I don't know if it's fair to call that a design mistake or just something, okay, well, that was learned and maybe in the future you might design it to be tested?
Well, yeah, I mean, you're actually hitting on what I would say is a fundamental engineering design principle that this is an excellent example for is, and it's called design for test.
Mm-hmm.
And if you can't get at the thing that you need to make it work, well, then you have to do, ad hoc dangerous things like I had to do. And when we design this, then we know we're running on a really short schedule. So, we had 3 years from, when the landers had previously crashed to when we had to make the next launch window.
Mm-hmm.
Or you're talking about hundreds of millions of dollars of cost and delay because you have to wait 26 more months before you can fly again.
Waiting for a time when Mars will be, because
literally waiting for the planets to align again.
Yeah.
And that happens every 26 months with going to Mars. So
our simplistic models from elementary school, it's not a bunch of concentric circles around the sun.
Yeah. Right? But I mean, it's kind of akin to, we put a hood on a car with a latch because we know we're going to need to get to that engine all the time.
Right.
And we put a dipstick into the oil pan because measuring the level of oil is important.
Right.
But, you can imagine, what if we designed a car without those two things? Mm-hmm. Cars would break all the time because we can't get at the parts.
Yeah. I mean, there's design for manufacturability.
Yeah.
Which is more the realm I've worked in, or you could think of like design for service. The fact that the dealer can fold down a little flap and plug in a diagnostic computer to access data.
Yeah.
That's all designed in.
And in this particular case, it was one of those things like you're designing one of the most complex pieces of electromechanical machinery that humanity has ever made.
Yeah.
And you realize that you need to test something, 2 years into the design process, and you don't have time to redesign it.
Right.
So that was, that was part of why I got the job, was that I was very familiar with all that stuff.
Yeah.
But, checks and balances and, I would say levels of consciousness factored into it. Another thing, even hard charging, dream chasing 20 somethings have their mental and physical limits.
Right.
And I was almost certainly past them that night. And, like many things, there are multiple things that lead to a problem happening. And, it turned out we found in the testing thing that we forgot to disconnect our test motor.
Yeah.
When we did the real test. So it actually looked like it was okay when we checked it out because, we didn't have things hooked up right in that thing. So that was a procedure step that was missed. The people who were working with me, weren't, didn't have access to double check the details that I had. So like all kinds of things that could have been done better, but it only takes one thing to mess it all up.
Yeah. And you were describing, Chris, you wrote the procedure. Did you forget to put that step in the procedure or forget to execute that step?
Well, I think in this case, it was just, there was so much going on that, the ability to plug things in two different ways was something that was easy to do. And that was not in the procedure.
Yeah. Yeah. So we can think of design and mistake proofing. Like, when something's being produced at volume, especially cars or
it's formally called idiot proofing.
Well, but see, I mean, you're being self-deprecating or humble. I always cringe when I hear the word idiot. I mean, clearly you're not an idiot, and the people working in other fields that make mistakes aren't idiots. So that's why I'll try to climb up on a soapbox here. Mistake proofing over idiot proofing, and even more in aviation, not aerospace. With the Boeing bolts that were apparently not reattached to the door plug. I read some commentator who, he's trying to be snarky or whatever. It's like, I don't want to die in a crash because some idiot didn't tighten the bolts. I'm like, that's kind of a human tendency to want to blame somebody instead of looking at factors like fatigue, time pressure, long day, etc. To be fair to you.
Yeah. It all gets into, the relationship between, people and expertise and skills and process and procedure.
Yeah.
And, we have process and procedure and checklists to anticipate and to, show the right way things do things. And then, the mistake proofing kind of comes in from experience, like in the aviation industry and in spacecraft as well. They have, I'm trying to remember the formal term for them, but it's safety wire on bolts to where, you often see in these really high end things, you got two bolts next to each other and there's a piece of wire between the two of them. So there's no way that the screw can back out because if that screw backs out, it'll actually tighten the one that's next to it. And anyone walking by can look at it and see that it's a little bit off. Or like if you've ever seen a semi or a bus and they have those weird plastic tabs with the little arrows pointing and they're all beautifully lined up, all pointing in the right direction.
Yeah.
That's a way to make it really clear that all those bolts are tight because none of them have loosened up, so these are, we build lots of airplanes, we drive lots of semis. So we've found production ways to address these problems. We don't yet, in most places, build lots of spacecraft. So we make it up as we go along.
Yeah. Yeah. On the frontiers of space and the frontiers of innovation, that's a different situation than building hundreds of cars a day. I mean, innovation versus production. But I want one other question I wanted to ask about the aftermath. We had that stressful night, and you thought they were going to fire you. Did you ever have a conversation with somebody like? Would they have fired you? Was it? Did you ever have kind of a mentoring conversation with Ernie or somebody? Or okay, well, what would have happened if it hadn't been brought back to life?
Yeah, well, that wasn't actually discussed.
Okay.
My sense now is it probably would have kept my job, and I don't know, either had fewer or more opportunities as a result. But the real lesson, the core lesson that I took away from the entire experience was, the manager of the project and a lot of other technical people that were involved in the design of these things that I was testing and were worried about, the rover still not doing what it needed to do because we needed to test all these things. And, there was a key question of like, should we continue to do this really dangerous test? And the ultimate decision was yes. Yes, we definitely should continue to do this dangerous test because the mission might not work if one of these things is broken. Yeah. And like the master stroke of management of the project manager is like, okay, we're going to do these tests and Chris will continue to do them because we have paid for his education and he will never make this mistake again. And now I was just shocked. I've learned since there's, stories about IBM that are very similar to this. Maybe this is where my manager learned this from.
Yeah. I think it's supposedly about founder Thomas Watson. There's a story.
Yes.
Yeah. From IBM. Yeah.
But, like I have lived that experience now and I know the brilliance of that decision is like, there's no better person on that planet to make sure that mistake never happened again. Because, those checks and balances that we should have had that I didn't realize when I drafted the procedures, like if I was going to run it 60 more times, I'm definitely going to make sure that it is the most perfect, beautiful, thorough, double-checked, absolutely correct procedure that's ever been written. Yeah. And every time I ran it from that moment on, I'd get sick to my stomach, just cringing is like, did we get it right this time? And I got it right every time since that. And I think the other thing where, the next sigh of relief I breathed was when Spirit was on the surface of Mars and it reached out its robotic arm and needed to spin up that motor to grind a rock. It worked. So it was all worth it.
Yeah. I imagine between the size and being able to launch it and everything, there probably wasn't an opportunity to build in a lot of redundancy. I mean, jet airliners used to have 4 engines. Now they generally only have 2 because the reliability is better, but they're not relying on one and they can fly a long distance if one were to go out. I imagine that type of redundancy just wasn't possible in this kind of application.
Well, it's hard to design redundant actuators for joints and things. It's like
Yeah.
the redundancy is like if one of your arms is not able to be used, you have another arm.
Sure.
Same thing with eyeballs and legs and
Yeah.
things. But you only have one heart. We didn't
Right.
figure out how to make the heart failure tolerant. So it's just very, very reliable.
Yeah. Yeah.
And we protect it well. So,
Right.
but that's also the kind of the philosophy of these things, like to make things redundant, make them more reliable, but it makes them less capable if you're working with a constrained set of resources. It's kind of the difference between maybe a gymnast and a football player. The gymnast might be able to do a lot of more different things, but the football player can do one thing extremely well.
Yeah.
But they have different muscle mass, of course.
Yeah.
So spacecraft and robots and things alike, you have to figure out the best way to manage that risk. And in the case of these rovers, the way they managed it was by building two.
Mm-hmm.
So one didn't work, you got another one.
Yeah. You had written this story, and like this is a rare instance for the listener. I knew the story because I had read it, and that's why I reached out to Chris. I often don't know the story that a guest is going to tell, but I've heard it in a different way here that prompts different questions than I might have planned for. You said earlier it took you a while to be able to tell the story. Do you remember about how long? I mean, was it years, a decade?
Probably only a couple of years. I think it's the type of thing where, it was a personal failure, but it wasn't a failure that, I guess the thing that we were doing didn't fail. So
Right.
there was a degree of comfort after these two rovers had been wildly successful. And it was one of those war stories you could talk about.
Yeah.
But I think it was, for me, like everyone is on their path of experience. One of the other things I learned is every person who has a responsibility like that really feels, there before the grace of God go I.
Mm-hmm.
So while I had expected a lot of people to lash out at me, accusatorily or, saying shoulda, woulda, coulda,
Yeah.
no one really did. What I really experienced, except for a brief moment of profanity, which was probably deserved.
In the moment.
In the moment, it was deserved.
Yeah, right. It's a natural human response, even if it wasn't deserved.
Yeah. But what I experienced was support. And
yeah.
I think the real thing to recognize is, and this is something the chief engineer of JPL now, my friend Rob Manning, has talked about. There are thousands of mistakes that are made in the process of building these things, but it's the way that we have learned how to build and design them that allows us to work through those mistakes happening anyway.
Yeah.
So, and realizing that the best thing you can do, and another friend, Lindy Elkins Tanton, who is the principal investigator of the Psyche mission on its way to a metal asteroid right now. She had once said in a NASA review that I was in her with, the best news is bad news delivered early enough to fix it.
That's great.
Yeah. Like bad news doesn't get better with age. So, the type of thing. I was holding the smoking gun in the clean room when I had just probably wrecked the rover. But, I immediately had to tell someone wouldn't happen. I can't hide it. No one's going to benefit by hiding it. The bad feeling's not going to get any better. So, the best thing you can do when you know that there's a problem is to tell someone else about it. Yeah. Because everyone is going to want to help you solve that problem as soon as you can.
Yeah. Yeah. And it's great to hear that you did speak up about it. There are times when, especially when there's fear of losing your job or worse, that people might choose not to, or if there's to deflect or, come up with some other feasible cause that was, not related to something I did like that. I bet maybe it was your sense of mission. I no pun intended with
Yeah.
a space mission, but the sense of commitment to what you were trying to accomplish, that it was necessary to speak up, even if it
Yeah.
wasn't easy. Or
Well, I think, it probably landed in its current form of, feeling about it when I was, a CEO of Planetary Resources, and these types of problems would happen in the team.
Oh,
People
yeah.
would come into my office nervous, sometimes crying. But my primary concern was like, was anyone hurt?
Yeah.
Like,
Right.
okay, no one's hurt. Oh yeah, this is a solvable problem then.
Yeah. Yeah.
So, it's the Jeff Bezos idea of reversible and irreversible doors and decisions or problems. It's
Yeah.
just a machine. It can be fixed. And, everybody is going to make mistakes.
Right.
It is the most human thing about us.
Mm-hmm.
We strive for perfection and rarely achieve it.
Right. Right. Oh, and that lesson's going to continue serving you and other leadership roles, or as you're coaching and mentoring others. And I hope anybody listening who's doing any sort of technical work. I mean, there's so many stories from Silicon Valley of the person who accidentally deleted the files for one of the Toy Story sequels, I think, and there was a backup to be found somewhere, thankfully. Or somebody deleting the production database, or stories like this.
Yeah. There were lots of, when I published the story, there were lots of IT professionals who had a lot of disaster stories to share of their own that, I could imagine felt every bit as bad as my experience.
Yeah. Yeah. So, in the piece, and I'll link to it in the show notes, I invite people to go and read it. And, I thought it was interesting, Chris, you invited people to share their stories, but I think maybe this was from our conversation earlier, not from the article, I don't think. But you started asking people about failure stories during job interviews.
Yeah, absolutely.
Can you tell us more about that?
So this was a process where, you only can know someone so much about someone's resume, or, referrals are great, of course, to kind of let you know the understanding or the character of people. But we would ask in our application at Planetary Resources, we'd have a brief thing is like, everyone who is doing anything challenging fails at something. What's something that you failed at and what you learned as a result of that? Yeah. And for us, it was really a way to match on culture that, we wanted people who had tried hard things, but we also wanted people who were humble enough, to realize that they don't always go like you would expect, and they're willing to learn from it. And like what we often found is like there was a type of person who, had some failure, and their primary description of it was it wasn't my fault. It was everything around me and this and that and the other thing, and I had no part in it, which I would say sometimes was true. Maybe not the type of failure story that we're looking for, but the other parts where the people would just kind of see the wisdom of like, I should have known, or it shouldn't have done it that way, or should have asked for help. The people where there's some introspection and just kind of on that continuous lifelong learning journey where it's risk and reward, and people often say it's not a failure if you've learned from it. It's just a lesson.
Yeah, there's lots of great variations on that quote, or to your point of we're all human. I've heard a variation of the quote along the lines of making mistakes is not a choice, learning from them is. Or the only real failure is failing to learn from the mistake. It's so true.
The interesting thing about it, and this maybe is the rite of passage of everyone standing. It's you can't learn anywhere near the same emotional experience of reading about these things than having these horrifying experiences yourself. The most surprising kind of corner of feedback that I got after I published my article was from a team of doctors at a hospital. And of course, you want them to be perfect. You want them to never make a mistake, but humans are humans wherever they do things. And in that profession, you absolutely want them learning from their mistakes and approaching things with humility. So, the idea of it with $500 million rovers or open heart surgery, the same elements are at play.
Yeah, I mean, there is, I think, back to the question of kind of building the first of something innovation versus production. I think there's different circumstances, and I've seen like Amy Edmondson from Harvard, her great book Right Kind of Wrong, that explores a lot of this. I'll credit her for this idea. The first time someone ever did a heart transplant surgery, like that's on the frontier of learning and innovation, and there could be something they didn't anticipate along the lines of what you hadn't anticipated with that rover, as opposed to I'm going to use knee replacement surgery that's gotten to be pretty darn routine, or laser eye surgery. That's almost more of a production process of you shouldn't cut into the wrong knee. So there's certain mistakes that we'd say, well, it's innovation, we need to learn from it, and then there's certain mistakes where you'd say, gosh, we shouldn't, we should be preventing that. But if it happens, let's learn from it instead of being punitive. That's me getting on my soapbox again a little bit.
I think, my life is now surrounded in commercial space, and there's certainly a lot of different and exciting things going on than any other time in history.
Yeah.
And there is a different type of mistake that actually relates to perfectionism. And the reason why things take very long and they get really expensive, and they ended up with antiquated technology in them, because we're striving for the perfect. In that case, the consequence of all that is it took too long, it cost too much money, and it didn't deliver results nearly as soon as it could because you were unwilling to take any risk at all.
Yeah, or you might miss the market opportunity altogether. And someone else launches before you.
Yeah,
software maybe not launching.
There's a spectrum of risk taking where, how do you take the thing you're trying to do and protect your downside in making mistakes, and maybe the risk of being stuck in conference rooms and having meetings for too long it's like, okay, well, what's the earliest we can try something to see if it works or doesn't?
Yeah.
And we'll learn more from trying to make this robot work that day than we ever would on a phone call guessing about it. Right. So, that's the type of thing where a culture of calculated bets and calculated risks. And again, I'll credit Elon Musk and SpaceX. They're the best example in history on this particular topic of having rockets exploding in mid-flight and being super excited about it because it was such a fast and inexpensive way to learn things.
Yeah.
And it's a little bit harder when you're landing on Mars just because the iteration cycles are longer. But, optimizing that iteration cycle with the risk that you're taking is key.
Yeah. Because there's testing. I watched a documentary recently about the Hubble Space Telescope. It was on Netflix, I think. And they were talking about the different things that could have gone wrong, from the unfolding of the mirrors to...
this is the James Webb Space Telescope.
About the Webb Telescope. Sorry. Yeah. My mistake. That's not a $500 million mistake. That's not even
That's a $10 billion mistake.
I should have just said the documentary about space telescopes. But, there were things that were concerned about around, I think, the solar... I'm going to call it like the tent type folding, or the vibration of launch, or landing on the moon, and it's a hard landing. I imagine there's certain things that you just couldn't test because it might be destructive. So you're weighing the odds. Back to your other question, even with your test.
This is another thing that I mentioned. Well, no, actually, I didn't mention this. It was a different call today. There was a lander that failed to land on Mars in 1998 called Mars Polar Lander. And what happened was they deploy the legs right before they're getting ready to touch down, and there's a touchdown sensor in the leg so it knows when to turn off the engines. And they deployed that touchdown sensor, and the touchdown sensor bounced like in midair because you're deploying this thing and it kicks in. But the problem was it was 600 feet up in the air when it bounced and got the signal to turn off the thrusters. And then it fell 600 feet and crumpled onto the surface of Mars.
Wow.
And what NASA learned from that particular failure was the idea of testing in the same way that you plan on flying the mission. And conversely, flying the mission consistent with how you tested it. And that as an ideal is anticipating everything that's going to happen and doing your best to emulate how it's actually going to happen. Sometimes, as you mentioned, you can't do that. You can't deploy a tennis court sized shield, thermal shield in microgravity without actually doing it in space.
Yeah.
But with this lander leg, the problem that they did is they never deployed the lander leg at the same time that they were running the sequence in the software to pretend it was landing. Because, they didn't want to use up the leg, so to speak, by releasing it too many times. But now, since that failure, NASA very much, is like deploy everything, move all the things, do every critical thing that you can do. Yeah. Because you want your software and your hardware to experience as close to the final reality as possible.
And designed to be landed more than once, I guess now becomes a criteria.
Yeah. Well, and this can go to like deploying websites and live events and all those type of things. Is like, if you're going to have 50 million people clicking on your web page, you should try to simulate 50 million people clicking on your web page. And what happens when people are putting credit card charges through at that rate. So, anticipating different things that can happen and stress testing your system, and what happens, when the soccer game happens at a different time of day and you're doing the server backup process, when the soccer game's happening and the servers are overloaded. So just kind of forecasting all those things that might actually happen in the real world that don't happen in your development environment.
Yeah. Well, again, we've been joined today, Chris Lewicki, his website, chrislewicki.com. I'll link to it in the show notes, and I'll link to that article. A couple quick questions here. I'll get this correct. I won't make a mistake on this. Another term you use to describe yourself, near futurist.
Yes.
What does that term mean?
It's the future that you can create by doing something this afternoon. I don't like to think 50 years into the future. I like to think, what am I working on right now that's going to happen in 5 years? So that's the type of future I like to think about. Yeah.
And then that mindset seems to be related to what you listed as a motto. I'm going to just read the first part and ask you to finish the sentence. Stop reading about it and
start doing it.
Seems like good advice for all of us, and a lot of great lessons here. Even for me to keep in mind, the work I'm doing is far lower stakes. There's people listening, I'm sure, doing high stakes work, and lots of great lessons. And thank you for being willing to share your story so candidly and with all of those reflections, Chris.
Yeah, it's been an absolute privilege to do so, and I'm glad it all worked out in the end.
So am I. So yeah, thanks again for being here, Chris.
All right, bye.